All right, like I told us at the beginning, X represents any halogen atoms such as chlorine, fluorine, bromine, or iodine. Yes, any halogen. While R and R prime represents any alkyl groups. All right, represent alkyl groups. Now let's say the placement of functional groups. The placement of functional groups. Now you see the functional group. You see the list of functional groupings. We see their names when they are used as suffix, and their names when they are used as prefixes. All right, you know what suffix means in English language. All right, suffix uh, or suffixes are words added to the end of a word. All right, end of a word. Why prefixes? You add prefixes to the beginning of a word. All right, so when you have COOH, that's a carboxylic functional group. When it is added as a suffix to a compound, the end name of the compound is oic acid, alkanoic acid, all right, propanoic acid, butanoic acid. Okay, a name as prefix, it cannot be used as a prefix, so it is only added as a suffix. And once you see COOH in any compound, the pronunciation or the nomenclature of that compound, the ending name of that compound was end in OIC, oic acid. Then COOR, all right, when it is used as a suffix, uh, uh, as an alkanoate, eight, alkanoate, eight, butanoate, all right, propanoate, all right, pentanoate, okay. But when it's used as a prefix, it is called alkoxy, all right. When it is used as a suffix, um, eight, all right, the ending name is eight. When it is used as a prefix, you have alkoxy, all right. Then COOH, uh, like I've explained that before, yes, COOH is only used as a suffix. Even when you use it as a prefix, it is still pronounced as oic acid, carboxylic acid. All right. Okay. CONH2 is only used as suffix. Also, that's amide, propanamide, pentanamide. All right. So that's for that. Then CO. Don't forget that CO is the ketones or propanones functional group. All right. When it is used as suffix, you have ONE, butanone, pentanone. All right. But when it's used as a prefix, okay, we use the word oxo. The same thing with CHO used as a prefix, we call it oxo. When it is used as a suffix, that's pentanal, okay, hexanal, propanal, all right. Then CN, carbon nitrile, when it's used as a suffix, and cyano, when it is used as a prefix. OH is all. We are all familiar with that. All, alkanol, butanol, propanol. All right, we are familiar with that. All, when it is used as a suffix. And hydroxy, okay, when it is used as a prefix. All right, then NH2 as a suffix is called amine. The ending name is amine, while as a prefix, the ending name is amino. Like you have amino acids. Are you seeing it now? Amino. All right. Cl, Br, and iodine. They are only used as prefixes. You have chloro, bromo, and iodo. Okay, quickly, naming of alkanes. All right, let's begin now. Let's start with alkanes. All right, so how do we name alkanes? The rules for naming alkanes: all nomenclatures, all pronunciations must end in ane. Okay, now for branch chain structures, the longest chain carbon should be identified and numbered. First of all, you pick the longest chain carbon. I've told us C1, when it is one carbon, that's met, MET. When it is two, when you have two carbons, that's ETH, ethane. All right, when you have three carbons, that's propane, C3, prop. When you have 4 carbons, that's but, but. 5 carbons is pent, 6 carbons X, 7 carbons ep. All right, 8 carbons oc, like that. 9 carbons non. All right, you have the pronunciations like that. Okay. Now number 3, the compound's name is derived from the alkane, which has the same number of carbon atoms as the longest chain. All right. For example, look at that example. You have CH3, CH, okay, having an attachment of a CH3 group. All right, then you have CH2 and CH3. Like I said, yes, in the preliminary stages of this class, I said if you want to number the carbon atoms, you can go from front to the back or from back to the front. There is no particular method, no particular way. For example, like saying you must start from the front to the back. That is the rule. No, it is not a rule. You can either start from the front to the back or from the back to the front, provided that the attachment you have carries the lowest possible number. If you are going from front to the back, so how do you do that? You go from front to the back and you go from back to the front. Then you check what is the lowest possible number on the attachment. Like this one now, this number 3. See the example there. See that 2-methylpentane. They went from the beginning to the end, from front to the back. 1, 2, 3, 4. If I decide to go from back to front, that will be 1, 2, 3, 4. The methyl attachment there, we have number 3. And that will be very, very wrong if you say 3-methylpentane. Can you see? But if you go from front to back, you have 2-methylpentane, which is the lowest number. All right. So you can go from front to back or from back to front, provided the attachment has the lowest possible number. Okay. So that's why we have 2-methylpentane instead of 3-methylpentane. Okay. Now see the next one. Number the carbon atoms in the longest chain, starting from the end nearest to the substituent. I've told us before, this is not a defined rule. You can go from the end to the beginning or the beginning to the end, provided the attachment, the alkyl group attachment, has the lowest possible number attached to it. All right, look at this one now. They went from they went from uh, they went okay descending order. You have 4, 3, 2, 1. Can you see? And the attachment R3, which is incorrect, like I explained before. Incorrect. When they went from ascending order from the beginning to the end, 1, 2, 3, 4, you see 2, which is the lowest number. 2 and 3, which one is lower? 2 is lower. So that's why the correct answer is 2-methylbutane, not 3-methylbutane. All right, number 5. The compound is named by listing the position of the substituent, the name of the substituent, and the name of the alkane. Okay, that's the orderly arrangement of naming compound. That substituent means the attachment, the CH3 attached to the second carbon atom. So you start from that. First of all, the number on it, which is 2. Then the name of the substituent, methyl, CH3 is methyl. Then followed by the longest carbon chain there, which is 4, which is butane. So you have 2-methylbutane. The number on the substituent, the name of the substituent, and the name of the alkane, the longest carbon chain alkane.